Happy day, children. Today we are going to have a session on states of matter. Okay, we begin directly with a warm up. Draw an image of face or a flower and color it in your notebook. Why does the shape of the tip of the crayon change when you color a picture? It is because some particles of the crayon are passed onto the paper surface as a result of rubbing. This shows that the crayon is made up of small particles. Now let's see what we are going to learn in this lesson. We are going to learn to differentiate between the properties and conversion of the three states of matter. Then we are going to learn about solute, solvent and solution. Then we are going to know about the various types of changes. Substances are made up of very tiny particles that cannot be seen with our naked eyes. These particles are called atoms or molecules. Going to the atoms, an atom is the smallest particle of substance or matter. Let's see. The fact is, John Dalton coined the term atom, meaning indivisible. Okay, molecules. Each and every substance has some special qualities of its own. These qualities are called properties of that substance. A molecule is the smallest particle of a substance that shows all the properties of the substance and is capable of existing independently. A molecule is made up of one or more atoms. For example, each molecule of water shows all the properties of water. States of matter. Matter is anything that occupies space and has mass. Matter exists in three states, that is solid, liquid and gas. These three states of matter occur because of the different ways in which the molecules of substance are arranged. We move to the solids. Objects which are hard or firm and have clear shape are called solids. In a solid, the molecules are tightly packed and in a specific pattern, thereby giving solids a definite shape. In a solid, the force of attraction between the particles is very strong. Solids do not change in size, and the molecules in solids do not move from one place to another. Most solids are hard, rigid and have a definite shape and volume. Going to the liquid, this is how the solids are. Going to the liquid, substances such as water, which can be poured easily and are neither solid nor gas, are called liquids. In a liquid, the molecules of particles are loosely packed. In a liquid, the force of attraction between the molecules is weaker than in solids. Molecules cannot move easily and therefore liquids flow freely. Liquid takes the shape of the container in which they are kept. Liquids have no definite shape and size. Going to the gases, substances which are in air-like form, that is neither solid nor liquid, are called gases. In gases, the force of attraction between the particles is extremely weak. In gases, the molecules vibrate and move freely at high speed. The molecules in gases are well separated with no arrangement, and therefore gases do not have any shape or size. Gases assume the shape and the volume of the container in which they are stored. Let's see to the fact is, one drop of water has billions of water molecules. Why do ice creams occupy more space than water? This is what I want you to think about and tell me. Let's move further. Change of state. Matter can change its state, that is, it can change its form. Thus, a solid can change into a liquid or a gas. A gas can change into a solid or a liquid, and liquid can change into a gas or solid. Oh no, my shirt is still wet. How will I go to picnic tomorrow, mother? Don't worry, Adi. I will put it in sunlight so that it dries quickly. See the changes in the states of matter. This is the circle which goes on. I want you to draw the sketch as to how solid, sublimation, deposition, gas and liquid, it goes on and on. Understood? Okay, change it from liquid it goes to gas, then it goes to solid, then melting. So that's how it goes on and on. These are the changes in the states of matter. I want you to draw this and label these things. Okay, what is melting? A process in which a solid changes into liquid. What is freezing? A process in which a liquid changes into solid. What is evaporation? A process in which a liquid changes into gas. What is condensation? A process in which a gas changes into a liquid. Okay, now let's see what this fact is about. Sublimation is a process where a solid changes phase and turns directly into gas without passing through a liquid phase. Example, vaporization of camphor. Deposition is a process where a gas changes phase and turns directly into solid without passing through the liquid phase. Example, carbon dioxide changes into dry ice. Can we go further to the types of change? Reversible and irreversible changes. Let's take this activity. Take a candle and light it using a matchstick. Leave it for some time. You will observe the candle melts. Take the melted wax in a container. Heat it on a low flame. Pour the liquid into a glass tumbler. Put a thread in the middle. Observe it after 2 or 3 hours. Wow, the wax has again begun to change into a candle. Isn't it beautiful? Please try this, okay children? Now changes which can be reversed to get back the original substance are called reversible changes. The change of state of water is a reversible change, but if we burn incense or stick or wood, it changes into ash. It is not possible to change ash back into incense, stick or wood. These types of changes which cannot be reversed into the original substance are called irreversible changes. Physical and chemical changes. Matter can change in different ways. These changes that take place are called physical and chemical changes. We see physical and chemical changes taking place all around us all the time. A physical change is a change in which the substance may look or feel different, but the internal composition of the substance remains the same. Physical changes are reversible changes. The most common example of a physical change that we can see often is water changing into ice on freezing. This is a physical change because the molecules remain the same. It is only water that has changed physically to form ice, but on melting, ice again changes into water. Similarly, cutting of wood and tearing of paper are physical changes. Chemical change is the change in which the matter changes into something completely different. When a chemical change takes place, the composition of molecules changes in such a manner that an entirely new substance is obtained, which has its own distinct property and molecular arrangement. Most chemical changes are irreversible changes. For example, burning of paper. When paper is burnt, it produces ash, and this ash definitely cannot be turned into paper. Did you get it? Then coming to corrosion, when iron is exposed to human air, it rusts and a red layer can be seen on it. This is called corrosion. As these substances are different from the original substance, corrosion is a chemical change. Combustion. Combustion means burning of a substance in air. When a substance burns, it forms smoke, gases and ash. These substances are different from the original substance. Thus, combustion is a chemical change. This is how combustion is a chemical change, and corrosion is also a chemical change. Can you see this ship? Now it's of no use. Why? Because it's fully corroded. Solubility of a substance. We know that there is space between the molecules of liquids. Let us see how this helps in solubility of a substance in a liquid. Solubility is the ability of substance, that is a solute, to dissolve in another substance, solvent, at a particular temperature. Solids and liquids. When the molecules of a solid find space between the spaces of molecules of a liquid, they mix with the liquid. Such a liquid is said to be soluble in that liquid. Liquids and liquids. When two liquids mix with each other completely, they are said to be miscible. If they do not mix, they are said to be immiscible. Take a glass of water, add a tablespoon of oil to the water. Stir the mixture. You will observe that the oil keeps floating on top and does not mix with water. Thus, water and oil are immiscible liquids. Okay, so this is water and oil, and we can see that the oil is floating. So definitely water and oil are immiscible liquids. Let's see the activity number 2. Add a few drops of red and yellow inks in a glass of water. Observe how the color spreads in the water. It happens because the molecules of color find space between the molecules of water and completely mix with it. Let's move further to the activity number 3. Take half of a bowl of milk. Pour some water into it. Stir the mixture. You will observe that the two liquids mix with each other completely. Here the molecules of milk and water find space between the space of molecules of each other. This shows that milk and water are miscible, whereas oil and water are immiscible. Now, gases and liquids. Some gases can dissolve in liquids. The molecules of gases can find space between water molecules. Aquatic animals like fish breathe in oxygen gas that is dissolved in water. Aerated drinks contain carbon dioxide gas. In fact, a large volume of gas is dissolved in these drinks under pressure. So, as soon as the bottle or can is open, some of the gas comes out in the form of bubbles. Now name the following. One solid soluble dissolved in water. One gas soluble in water. One liquid miscible in water. Now you have learned from here, so write it on your own. Okay, now properties of substances. Different substances exhibit different properties because their molecules have different properties. Let us study a few of these properties. Thermal conductivity. Molecules of some substances carry heat easily. Substances that carry heat are called good conductors of heat. For example, iron, copper, gold and silver. Molecules of some other substances are not good carriers of heat. Substances that do not carry heat are called bad conductors of heat or insulators. For example, plastic, wood and rubber. Electrical conductivity. Okay. Substances whose molecules can carry electricity are called good conductors of electricity. For example, aluminium and copper. Electrical wires are made of aluminium or copper because they can carry electricity through them. Molecules of some substances cannot carry electricity through them. Such substances are called bad conductors of electricity. For example, wood and rubber. Magnetism. Molecules of some substances are attracted by magnets. For example, iron, cobalt and nickel. These substances are strongly attracted by magnets and are called magnetic substances. Objects such as wood, glass, plastic and rubber are not attracted by magnets and are known as non-magnetic substances. Expansion and contraction. What happens when an object gains or loses heat? I can't get the cap of this jar. No problem, John. Just place the jar upside down in hot water. Wow, the jar can be opened easily and the chocolates are now mine. Let's move further. When an object is heated, it expands and increases in size or volume. When it is cooled, it contracts and decreases in size or volume. For example, when an electric kettle is filled with excess water, it will spill out of the kettle when it starts to boil. Why? Different objects expand at different rates. Generally, liquids expand more than solids. Gases expand more easily than solids and liquids. Now, let's wind up with the summary. Matter exists in three states: solids, liquids, and gases. In solids, the molecules are tightly packed and so they have a definite shape and size. In liquids, the molecules are loosely packed with little free space and so liquids take the shape of the container. In gases, the molecules are loosely packed with a lot of free spaces and also move at a very high speed. Matter can change form, that is, convert from solid to liquid or gas, liquid to solid or gas, and from gas to liquid or solid. A physical change is a change in which the matter changes, but not the molecular composition. A chemical change is a change in which the matter as well as the molecular composition of matter changes to form something new. Well, children, this is the end of this lovely lesson, States of Matter. Happy listening. Have a nice day and thank you.